How's it going, geometry students? This is Mr. Hobbig. We're gonna do some good triangles. Here we go, baby. Now we're really starting to cook. I love this part. Oh my gosh. Okay, so the student will apply SSS, SAS, AAS, ASA, and HL to prove triangles are congruent. So, in the last lesson, we used in the proof, if you don't recall, the definition of congruent triangles to prove that triangles are congruent. Well, that is completely inefficient and a ridiculous thing to do. Usually, you can figure out a triangle's congruent way more quickly than doing all 6 of the parts. And that's what this lesson is about. So let's talk about it. If 2 triangles are congruent, the definition CPCTC, which means the corresponding parts of congruent triangles are congruent. Okay, says that, well, the congruent corresponding parts, I guess, parts of each triangle are congruent. Yeah. However, it is not necessary the congruent corresponding parts of each triangle are congruent. That doesn't make any sense. The triangles corresponding parts of each triangle are congruent. I'm not sure what goes here. That's interesting. I guess we'll say triangles. However, it is not necessary to compare all 6 parts. Sometimes 3 pairs, I guess 3 pairs of congruent corresponding parts will guarantee that 2 triangles are in fact congruent. Okay, so here is the postulate. The postulate is SSS. S stands for side. So this is side, side, side. Okay, and it states if you have 3 sides in one triangle that are congruent to 3 sides on a different triangle. So let's say we have A, B, C. We don't need that. So if your sides are congruent, pair 2 and pair number 3. If you have 3 pairs of congruent sides, then your triangles are congruent. Okay, I don't know why I put an apostrophe there. It just feels right. But it's plural, it's not like ownership. I don't know. Just a habit I got. Anyways, in a triangle, an angle is said to be included between 2 sides. Okay, here's where something gets intense. Included is very important for these theorems. So an angle is said to be included between 2 sides. So that means, like, if you look at this triangle, all right, we have 3 sides and 3 angles, right? Well, in this case, a side is included between 2 angles. In this case, angle A here is included between the 2 sides that make the angle, between AB and AC or CA. So this angle is included between the 2 sides. It's getting hugged by both of them, y'all. It's included. Hey, include me, guys. Oh, of course, we'll include you in our hug. That's what's happening. Okay, AC, this side, is included between angle A. Oh, excuse me. That's not AC. AC, which is this side, is included between angle A and angle C. Hey, I like to be included too. So the angles can include sides. The sides can hug the angle. Isn't that nice? These angles want a hug. Are they going to include this side? Sure you are. It's the only way. I don't know. I don't know how else to make it. So like, let's look at these. Now this side right here is not included by the angles. You see? It's over here. C doesn't want anything to do with you. Get out of here. Sorry. But this side right here, it's included between these two angles. I hope that makes sense. Another way to look at it is angle A. The letter A is actually in both sides. Okay? And then AC is the two angles. See that? That'd be another way to say it, to look at it. It's included in the name. I don't know. Whatever way works for you. So what angle is included between AB and BC? Okay. Well, if we look at the shape, AB and BC. Here's AB right here. Here's BC right here. What's the angle included? Oh, it's this angle. This is the angle getting hugged on. Or angle B, right? It's the one that is in both names. Let's go on. What side is included between B and C? Well, if you look at the name, it's BC. B and C? BC. But let's look at the picture. Here's B, here's C, here's BC. It's included. C is included between what two sides? Well, here's C. It's included between the two sides that make it, or the two sides with a C. So that's going to be BC and CA. All right, here's BC, here's CA. What side is opposite A? Okay, now we're switching it up. Okay, so here's angle A. The opposite of A is going to be the side that A makes. We kind of talked about this before, how angles kind of determine how big their opposite side is. Maybe it's the other way. It's not really either way, but that's how I think about it. If I open a door wider, then it makes the line between, like, as I open the door, it doesn't make the door bigger. It doesn't make the door frame bigger. It makes the hole between the door and the door frame bigger. You know what I mean? So it's like, if you look at AC as the door and it's opening, the bigger A gets, the bigger BC gets. You know what I mean? It's kind of how I think about it. Anyways, so the side opposite A is the side that is that doesn't touch A. Another way to think about it is, what's the side that doesn't have an A in it? There's only one of them. It's BC. What angle is opposite AC? Well, it's the letter that I didn't say already. It's angle B. Let's go over here. Here's side AC. This is the angle that's opposite. Notice how it's the smallest angle and it made the smallest side. See? There's some sort of correlation there, right? Or is it a causation? I don't know. Okay. SAS, so these are some other postulates and theorems. SAS. Okay, so the reason why we needed to tell you what included means is because SAS is talking about two sides and the included angle. That's why the angle's getting hugged by the S's. The two sides and the included angle are congruent. So if these two sides and these two sides are congruent and the included angle is congruent, then that means the triangles are congruent. We don't have to do all 6 anymore, guys. We got all these postulates that are going to help us say. So once I do that, right, then what happens? Then the party can start. I can say this is congruent to this. With definition of congruent triangles, I can say this is congruent to this now. Like, all I have to know is that the triangles are congruent, and then I know all my corresponding sides are congruent. You know what I mean? All right. So ASA, guess what that is? It's 2 angles and an included side. So here's my 2 angles. Let's say we use this angle is congruent to this angle. This angle is congruent to this angle. Well, The included side is congruent. If I can prove this sort of action, then that means my triangles must be congruent to each other. Okay? And this is a theorem. This is one that would have to be proved. These are more observations. It's hard to prove them, but it's like always true. It's kind of weird. AAS is angle, angle, side. So angle, angle. So two angles and a non-included side. So this one is congruent to these. If that's true, then you can also say that your triangles are congruent. Okay. And then you have this other postulate. Only works with right triangles. It's called hypotenuse leg. That's HL. Hypotenuse leg. So it only works with right triangles because, well, there's a reason. But hypotenuses are only on right triangles. Okay? So when you see hypotenuse leg, talking about a right triangle. Hypotenuse leg to hypotenuse leg means your triangles are congruent. So if I have if my hypotenuse is congruent and one of the legs is congruent, then you're good to go. If I had both of my legs congruent, that would also be fine, but it would be different. It would be actually SAS. Because it would be like, this is an example. This is not really notes. I'm just showing you something. If I knew this side and this side was congruent to this side and this side, then, and the right angles are congruent, so that's SAS. See, the right angles included. This is kind of a special case. What makes it special? It's that right angle. What is this actually? Let's see. Let's say it's an angle. So this is side, angle, side. This is angle, side, angle. This is angle, angle, side. And this is angle, side, side. Oh, I'm not going to write it. But I was going to write it. That's a naughty word. So this is the trick. There is no angle, side, side. It's not a thing. This is not a postulate or a theorem. I want to show you a way to give you a counter example. Why doesn't angle side side work? So here is angle side side. Let's say this angle's or actually, let's say this angle's congruent. This side's congruent, or no. This side and this side. Okay. Now check this out. Is it feasible to say that these angles might be congruent? Like if I drew it correctly, it could be feasible. I kind of messed this up already. Okay, so I did mess it up. Okay. Is it feasible to say these sides are congruent? Yeah, they could be the same length. Is it feasible to say this and this is the same length? Like they're pointed in different ways, but they could potentially be measured the same. But for sure, these triangles are not congruent, right? Yeah. So that's why angle side side doesn't work. Because it doesn't prove that your triangles are congruent. There's one other way it could be, and it has to do with this kind of weird, it's almost like a supplement here. It might be a supplement. I don't remember if it's a supplement or not, but like this angle, I'm going off track and I apologize, but this angle and this angle, I want to say they might be supplements, but they might not be. But anyways, it's this kind of real This doesn't prove that triangles are congruent. That's the main thing. So if you find yourself writing down a naughty word to justify something, that means it's not congruent. Okay. Don't write naughty words. Yeah, animals. Okay. Okay, can the two triangles be proved congruent? Okay. So we're going to be looking at these triangles as examples and determining if they're congruent or not. All right. So I have an angle, side angle, angle, side angle. Oh, yes. Angle, side angle. All right. Easy, right? What about this one? I got a side and a side. I don't have a third pair, do I? Or do I? With reflexive property, this actually share a side. So it's actually a third side. So yes. Side, side, side. All right, let's take a look over here. I only have two again. Is there another way I could find a congruent angle or side? Well, side's going to be difficult to prove, but we got this guy. Why are these congruent? Do you know why those are congruent? Side angle, side. It's called vertical angles. So if those are straight lines and not like weird hitched lines, you just kind of have to assume they're straight. Then it's side angle, side. What about here? Ooh. Is this side angle, side? No, this isn't the included. If it was included, it would be this one. But it doesn't say those are included. They sure look the same. But are we proving anything here? Or is this angle, side? So, oh, I almost wrote it. See, angle, side, side. That's really what it is. If you find yourself saying the twisted sister of angle, side, side, this is also wrong. Okay, so side, side angle. So this is no. You ever write this, or you ever write the forbidden word? Let's get it out of here. Oh my gosh. In fact, let's go back up here. This is only for the video. Get it out. Get it out. It's just a video Easter egg. Let's write this so that no one ever knows. Okay. All right. Side, 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 side angle, side angle, side angle. Okay, whatever. Okay, what do we have here? Are these congruent? Well, this is three pairs of congruent sides and angles. But what's the problem? This one is included, but this one is not. This is some side, side angle stuff. So that's going to be a no. Because they're not corresponding. They're not in corresponding places, right? Side angle, side. I have side, side angle over here. Or you know what? Okay. What about over here? Well, we have a shared side. So that's good, right? Is this good? Pretty close. No cigar. These are congruent, and these angles are congruent, and this third side is congruent, but this angle is not the included angle. If this angle were over here, we'd be doing good, but it's over here. So this is a no. Because the corresponding parts have to be congruent. Not just any three parts, but the corresponding ones. Okay, what about over here? Angle, angle, angle. No, that's not one either. This could be huge. This creates similar triangles, which means that they means a lot. Means same shape, right? But they can be massive or really tiny, and they'll end up with the same angles. So it does not create congruent things. This is the other one that is not congruent. Okay, what do we have here? Ooh, I got a right angle. Maybe we should look for a hypotenuse leg. But we got this. That's another angle. So right angles are congruent. This angle's congruent. We got a shared side. Angle, angle, side, angle, angle, side. Yeah. That is the theorem. That's the only theorem. But it is true as well. Okay, we have, what about here? Here's the right angle. We have side angle, but with the right angle, it does work. And it's called hypotenuse leg. Hypotenuse leg is the good sibling. It only works with right angles, but that's the only way you can get that side angle. All right. Easy peasy. So, triangles are so fun, you know. This is when geometry's finally fun. I'm so glad we're out of that algebra unit. Okay. Let's do our guided practice. I have water. If I had water, I'd be drinking it to give you guys a minute, but I don't have any, so I guess we gotta get started. Here we go. If the triangles are congruent, complete the congruence statement. And then you say this. If you can't tell if they're congruent, write no. Okay, so good. Why didn't we do a congruent statement before? I don't know. But you need to know your corresponding parts here. Okay. Let's pretend this is what this says. Okay, so we got parallel lines here. Parallel lines don't mean congruent segments. We do have a shared side here, so that's a good sign. What can parallel lines tell us, though? What did we learn about last unit that parallel lines can tell us? What is congruent with parallel lines? Well, all those angle pairs, right? Corresponding, alternate exterior, and the all-important, the one that's going to come up most, is the alternate interior angles, or the Z angles. Can you find a Z here? Here's a Z. You can flip your Z around and do whatever. But that's a Z. So the inside corners of the Z are going to be congruent. Oh, but these are parallel too? Is there a Z here? There is. Remember, the bottom and top of the Z are the parallel lines, so I guess these are congruent too? Okay. Now what do we got? Angle, side, angle, angle, side, angle. So we are going to use ASA. Let's make our congruent statement. Triangle ABC is congruent to. Okay. This is where it gets tricky. Now, everything's congruent, right? So, A and D are going to be corresponding vertices. Oop, why did I write A? It's a D. This is where it gets tricky. This is where you're going to fail. Not fail, but, you know, mess up. Okay. The C here is congruent to the B. And the B is congruent to the C. The B, the 2 is, and the 2, that's the 1 and the 1, right? So it's not B corresponds to B. It's actually B corresponds to C, and B corresponds to C. So where it says B here, you actually write C, and then B. Because remember, the corresponding parts are congruent. So on ABC here, the B is actually congruent to the C on the other triangle, the DCB. Okay. Hope that made sense. This is a shared side here, so we're going to say that's congruent. Pretty much got it. Side, angle, side. Good to go. So triangle ABC. Okay, so if side, angle, side this time, C is corresponding to C. So that means A has got to correspond to A. And then B is going to correspond to B, D. So A is congruent to A and A. And then B is with D. And C is with C. And why? Because of SAS. I didn't know this stuff, so I'm just going to erase it. Okay, here's another one. Angle, side, angle. My congruent statement. It's telling me to write triangle ABC. So that's why I'm always writing triangle ABC. Is congruent to A is the right angle, so N B is the one that isn't congruent, so P. And then C is congruent to Y, so make sure those are lined up. Just look at the angles. You have to look at the sides so much. Okay. I mean, if you can't figure out P and B are corresponding, I don't know. Okay, what next? This shared side is true. Uh-oh, we got a side-side angle situation, side-side angle. But with the right triangle, we can do HL. So we're going to do HL. Triangle ABC is congruent to. Okay. A corresponds to S. B and B, the right angles are congruent. And then C is with C. So ABC is congruent to triangle SBC. Okay, watch out for that SSA. And you know what else. But if you got the HL, remember that's the good one. So another big important thing is, what does included mean? Make sure you know included means that it's between the two other things. So you got angle, side, angle. Only works if the side is included between the angles. And we'll end it there. Let's look quick sneak peek. All right, so it's more just looking at a bunch of crazy triangles. Don't forget about Z angles over here on 13. Ooh, look at this shared side. Yeah. Looks good. Congruent statement. Easy peasy. Given all these, what's the correct congruent statement? Ooh, that's a tricky one. Good luck on that one. That's a good one. Just remember, corresponding parts are congruent. All right, y'all. Have an excellent day.